Here we have a SAT math problem. Okay, let's go to the question. The elastic potential energy in joules is the energy stored in a spring when it is stretched. The elastic potential energy is directly proportional to the square of the distance that the spring has been stretched from its original length. When a spring is stretched a distance of 0.5 meter, the elastic potential energy is 12 joules. If the spring is stretched 0.25 meter, what is the elastic potential energy in joules stored in the spring? Okay, now let me assume y as the elastic potential energy and x as the distance. Okay, let me write the stuff over here. According to the information, the elastic potential energy is directly proportional to the square of the distance. That is y equals to kx square. So when y is directly proportional to the square of the distance, that is a square of x, we have to write the equation like this. In case if the elastic potential energy is inversely proportional to the square of the distance, then we will be writing the same equation as y equals to k over x square. But here we have a direct proportion. So we have to write equation like this, and here k is the constant of proportionality. So using the stuff over here, we have to get the value of this constant k. So that is here we know that x represents a distance and y represents a elastic potential energy. When x equals to 0.5 and elastic potential energy, that is the value of y is 12. So let's plug in this 0.5 for x over here and this 12 for y over here and solve for the constant of proportionality, that is k. Okay, now let me do it. Then we get 12 equals to k times 0.5 the whole square. Okay, let me continue over here. That is 12 equals to k times. When I evaluate the value of this one, that is 0.25. Okay, now let me divide both sides of this equation by 0.25. Let me do it. So here 0.25, 0.25 will cancel out. Okay, when I divide 12 by 0.25, I am getting 48. Okay, here we get 48 on the left side, on the right side we got k. Okay, here I got the value of the constant of proportional to k. Now we can plug in this 48 for k over here so that this equation will be complete. Then we get y equals to 48 times x square. Okay, our aim is to find the elastic potential energy, that is the value of y when the distance, that is the value of x, is 0.25 meters. So in this equation, I have to plug in this 0.25 for x over here and evaluate the value of y, which represents the elastic potential energy. Okay, let me do it. 48 times 0.25 the whole square. Okay, here when I evaluate 0.25 the whole square, I am getting 0.0625. That is 48 times 0.0625. Okay, now let me multiply 48 and 0.0625. When I multiply them, I am getting 3. Okay, here when the distance is 0.25 meter, I mean when the spring is stretched 0.25 meter, the elastic potential energy is 3 joules.